Feature flags, also referred to as feature toggles, are a powerful way to change application behavior without changing code. They allow features to be turned on and off dynamically. The .NET Core Feature Management Library extends the framework with comprehensive feature flag support. This library is built over the .NET Core configuration system. Any .NET Core configuration provider is capable of acting as the backbone for feature flags. In this video, let's learn more about feature management libraries in .NET, how to use it from an ASP.NET Core application, and the different configurations and support that these libraries provide us to build in feature flag support. Now, I would suggest to start using feature flags right from the beginning for any new features that you are building. This gives you the ability to turn on and off a feature based on various conditions. Hello everyone, welcome back to another video in my ASP.NET Core series. If you're new here, my name is Rahul and I usually make videos on .NET, Cloud and DevOps. Without much delay, let's head off straight into my command line and create a new .NET Web API application to start exploring the feature management libraries. Let's use the .NET CLI and specify the new command and create a web API. This is going to create a web API template into the current folder. Let me open this up in an IDE. I'll use rider and then specify dot to open the current project. I have the application opened up in rider. So here we have the program.cs, the startup.cs and a default controller, which is the weather forecast controller. This is a default web API application. So let's start adding a feature flag inside the weather forecast controller. The simplest way that you can think of adding a feature flag is to use a boolean that's injected into the code. Based on the boolean value, you can turn on and off the feature that you are building. But most times with feature flags, it might not be a simple boolean condition. You might have various other conditions based on which you might want to enable or disable a feature. So rather than using a simple boolean value, let's use the .NET Core Feature Management Library. If you navigate to Microsoft Feature Management-.NET in GitHub, you can see the Feature Management Library. I will put a link to this in the description below. This library supports various features based on which you can enable or disable features inside your application. Switching back to rider, as expected, to use the new library, we need to install a NuGet package. So go into Feature Flags, right-click and say Manage NuGet Packages. Let's search for Feature Management.ASP.NET Core. Here, you can see that there is a library which is Microsoft.FeatureManagement.ASP.NET Core. This is the NuGet package that we need to install to start using the feature management libraries. The NuGet package is successfully installed, so let's start using this from our controller class. To start using the feature management libraries, let's inject in a iFeatureManager into the weather forecast controller. So here, this is coming from the Microsoft.FeatureManagement NuGet package that we just added. So let's select that and specify a name, Feature Manager. Let's add a backing property for this in this current class so that we can use this inside the get method. The get method currently returns an enumerable of weather forecast. Most of the data is hard-coded inside this controller, so let's keep it that way. In this, it currently returns the date, temperature, and summary. So let's say we want to add a new feature which indicates the chances of rain happening on that day. Let's add a new property. Let's call this rain expected, which will be a percentage value. So let's use string interpolation and specify the range.next and choose a value between 0 and 100. So we can also specify a percentage right after the curly braces. So this is going to add a new percentage value inside this weather forecast object. Let's make sure to create this new property inside the weather forecast class. So this is set as expected. So now instead of returning just the temperature, we also return back the property rain expected. Now let's say while building this feature, we want to feature flag this because we are not sure when this will be deployed into production. So we'll need to give an ability to turn on and off this functionality as we develop it. So let's start using the feature manager to determine this. So let's say is rain enabled, which will be a feature flag. So we can get the value from the feature manager. So let's say underscore feature manager dot is enabled async, and then specify a string which is resembling this feature. So let's call this as rain enabled, and we expect this to be set somewhere. So for now, we can simply use the is rain enabled to set this property as a valid value or return a null. So let's use is rain enabled. In this case, return back the string. If not, set this to null. So since this is an async method, I will need to make sure that I add an await. That also forces me to add an async on this method. With rider, I can simply use alt enter and specify make method get async. So I now have this method returning the rain expected based on this is enabled or not. The feature management library is built over the ASP.NET Core configuration system. So this property can be enabled or disabled in any of the configuration sources. If you're new to configuration in ASP.NET Core, I highly recommend checking out my video on that, which will be linked here or in the description below. Now, to add a value for this rain enabled, let's go into the app settings JSON and provide a value. Since this is a development environment, I will put all my feature flag values inside the app settings.development.json. So I can go into there and specify this new value. By convention, the feature management library expects the value to be under the key feature management. So let's specify feature management and add in the feature flags that's there for our application. So in this case, we have the rain enabled feature, and then we can specify this to be true. Now that we have added a feature flag inside our code and also specified a value inside the development.json, let's go to our startup.cs and register the feature manager libraries. So under the configure services method, this is where we set up our dependency injection. You can specify services.add feature management. This is again coming from the Microsoft.featuremanagement NuGet package that we just added. So let's select that and make sure to remove this empty line. Now, if you're not sure about dependency injection inside .NET and how this works, you should definitely check out the video linked here, which talks more about this. With that set up, let's run this application to see this in action. Now, inside the development environment, we have Swagger enabled for this API, so this is going to launch a Swagger UI. The application is running and it launches the Swagger endpoint as expected. So let's go into the get weather forecast, try it out and click execute. This returns back the data as expected. Now we have the rain expected as a value that's being returned back. Now each of these objects has a random value being set. If I switch back to rider and update the app settings.development.json to make this as false, this is going to automatically reload the configuration. So the next request that I make is going to return this as null. So let's navigate back and make another request to this endpoint. Now here you can see that the rain expected is now returning a null value. This is because the configuration provider is set up to automatically reload any changes to the config files that we make locally. Now when building this feature, you might want to turn off this property altogether from the returned value when it is null. To do that, inside the configure services, when we add the controllers, we can also call the add JSON options method. This allows us to pass in a JSON option and override the setting for the JSON serializer option and set the null handling to be ignored. So there is an ignore null values and set this to true. So any null values inside the response will be ignored. Let's run this again. And here we now don't have this rain property at all. If we go back and enable the flag to be true, we'll start seeing this in the next request onwards. Now that we have this new feature, let's say we decide to go on and add a new endpoint inside our weather forecast controller. So let's simply copy this for now and paste this below. Let's call this as an advanced endpoint. So let's say get advanced, which is going to return advanced weather metrics for that particular days. To provide a different route for this get advanced method, let's pass in the route inside the HTTP get method. If you're not sure of the different formats that you can specify, please do make sure to check the video linked here. So let's specify this as advanced, which will create this as a /advanced endpoint. For now, this is simply returning the same data, But let's say we want to feature flag this advanced endpoint as well. Rather than having to do an if-else check inside of the whole method, we can simply add in a new attribute which says feature gate. This again comes from the Microsoft feature management libraries, so we can specify feature gate and also pass in the value of the flag. So let's call this advanced enabled. So to enable this, we will need to copy this again and go to app settings.development and paste in this value here. So we have a new flag, and let's make this to true as well. Let's run this to see this in action. The Swagger UI now shows the other endpoint as well, which is weather forecast/advanced. So let's select that and specify try it out and click execute. This now returns the data as expected because the feature flag is enabled. If we navigate into the feature gate attribute that we just added, we can see this is nothing but an action filter attribute. We had learned about filters and how these works in an earlier video. Now using this action filter and the feature flag that it is enabled for, this simply looks the value inside the feature management inside its code. So if we scroll down, we can see that this uses a iFeatureManager snapshot from the context to retrieve the feature manager value. Now based on this value, it decides to call the next method or not. Now if the flag is enabled, it calls on to the next and awaits for that return. If not, it simply uses the iDisabled feature handler and returns whatever is for the disabled feature flag endpoint. Now by default, it is configured to return a not found disabled features handler. If we navigate further into that, we can see this simply returns a 404 status code result. You can override this by creating a new implementation for this interface inside our application. So if we navigate back to the app settings.development.json and turn this feature to be false and switch back to Swagger and click execute again, this time we will see a 404 as expected. The feature gate attribute that we added at the action method level can also be specified at the controller level. This means all the functions and endpoints inside that controller will be disabled based on the feature flag. The library also supports extending in the MVC filters, so when you are adding a new filter, you can use the add for feature and specify the feature flag. So this filter will be enabled only if the feature is enabled. Similarly, you can use this for middleware as well. You can explore this inside the documentation in the GitHub page itself. Up until now, we have simply used boolean values to represent our feature flags. But let's say we have more advanced use case scenarios. Let's see one of them next. So while building the advanced API endpoint, let's say we have completed all the work, but then we also figured that there is a new algorithm that we could use to determine the weather data for that particular day. So let's refactor this into a different method and call that the old algorithm. So let's use control RM, which extracts method inside Rider. This is also possible inside Visual Studio. So let's call this as old algorithm. Now this creates a new method. So let's copy and paste this because I have the new algorithm exactly as same, just for demo purposes. So let's call this new and return the same value again. To make sure we can understand the difference inside the rain expected, let's simply add in the value old, so that this can be used to identify whether the old or the new algorithm is being used. Now inside the await algorithm, I can simply use a new feature flag. So let's say use new algorithm, which will be the feature flag. So let's call await and the feature manager to get the value for the feature flag. Let's call this new algorithm enabled and use this feature flag to return the old or the new algorithm. So let's say use new algorithm. In this case, let's await and return the new algorithm. And if it's turned off, let's use the old algorithm. So let's specify the colon and use this to return based on the feature flag. So let's copy this value, navigate back into app settings.development. So this time, rather than simply using a boolean value to either turn on or off, let's say we want to roll out this new algorithm slowly to our customers. So maybe only 50% of the customers that's hitting our endpoint will be on the new algorithm, while the rest would be still served up on the old algorithm. To do that, we can specify the curly braces and specify the enabled for property, which takes in a list of feature filters that can be specified. So since this is a list, let's specify this as an array. Let me copy and paste a configuration. So this adds in a Microsoft.percentage filter, which as you can expect, specifies a specific percentage based on which the feature flag needs to be enabled. This is built in with the feature management library again, so I can simply use this and specify the parameter value as 50 because I want 50% to use the new algorithm and the other to use the old. Now to start using the percentage feature filter, in the startup.cs, when we register feature management, we also need to register the percentage feature filter. So let's specify add feature filter and pass in the percentage filter. So this registers this particular filter along with the feature management libraries. Let's run this application to see how this is working now. Let's navigate to the advanced endpoint and try it out and select execute. Our advanced endpoint is turned off, because of which we get a 404 error. So let's switch back to Rider, go to the app settings.development.json and turn on the advanced enabled. So let's make this as true and hit the endpoint again. So this time we get back the value for the rain expected. This is using the new algorithm because we don't have any old specified inside the 41%. Let's click execute again. The next time also we have got from the new algorithm. The third time I make, you can see here, we get the rain expected and it still retrieves the value from the old algorithm. So based on the number of requests, it keeps switching between the new and the old algorithm. On an average, it will be always around 50%. So now the next request that I made also returned an old, so possibly the next one will be new. So this will keep switching between the old and new so that it is approximately around that 50% on an average. You can go and adjust these values as you want inside your configuration. With this, we are successfully able to phased roll out the new algorithm feature that we added for the advanced endpoint. Similar to the Microsoft percentage, there are a few other built-in feature filters as well. So we have the Microsoft.time window, which as you can expect specifies a start and an end time during which the feature can be enabled. You can also use the Microsoft.targeting, which is more advanced and specifies targeting based on users, groups, the roles that they belong to, etc. So you can also give a default rollout percentage, which happens when none of these categories meet. Now to understand more about the targeting filter, I highly recommend checking out the documentation here. If we navigate into the percentage filter, we can see this implements an I feature filter. So using this, we can also write custom filters. Let's see how we can do that as the next example. So let's open up the Solution Explorer, add a new class to add a new filter. So let's call this as browser filter, because this is going to be a filter based on the browser that you are accessing the API. I have this filter written out. Let me copy and paste that and make sure to import all the missing references in this file. Now here I have a class browser filter and I have implemented the I feature filter interface. Now this simply adds in the evaluate async method, which evaluates based on the feature context. The custom filters that we write can take dependency injection from service collection. So here you can see I inject in the I HTTP context accessor into this class. Using this accessor, I check the user agent to see if it matches a specific value. So when I create the browser filter, I will have to pass in the value of the expected parameters. So this is passed in through the feature context. Now from the context, I can retrieve the browser filter settings. This passes in a string of allowed values. Now this browser filter settings is very similar to the percentage value that we specified for the Microsoft percentage filter. So this class is going to represent the values that's going to come as parameters in here. Navigating back to the browser filter, you can see this simply looks at whether the settings has any values enabled based on the actual header that's coming in the request. So any request that comes in, we get the header from the user agent and matches that value inside the configured settings. Now to start using the browser filter, like we enabled the percentage filter, inside the startup.cs, we need to make sure we call the add feature filter and specify the browser filter as well. Earlier, when we specified the new algorithm enabled, we had specified this as an array. This means this can take in multiple values that is expected to turn on or off this feature. So in this case, let's go and use this new custom attribute that we have added. So let's specify a new object, pass in the name. In this case, we can simply use browser. This is because inside the browser filter, I had specified an alias and given it as browser. So this is how we can refer it inside our configuration files. Navigating back, let's pass in the parameters. So let's again use the same format, pass in parameters. In our parameters, we expect the value allowed, which is the browser filter settings. So let's copy this property, navigate back and add this inside our configuration. Now let's say I want to allow this only for the Edge browser. Now since this browser filter simply looks contains to check whether any of this value is inside the user agent, I can simply specify as EDG. I know this because if I go to Google and look for user agent for Edge and navigate to this site, we can see the possible user agents that is for Edge. Now based on the version, this is going to differ. So some of these versions have EDG and some of them have EDGE inside them. So I can simply use EDG for this demo. Now since for the browser filter, we have used the HTTP context accessor, we need to go into startup and make sure to register that in the dependency injection as well. So let's call services.add HTTP context accessor to register this interface. Navigating back to the browser filter, we can see the allowed is a string array property. So let's make sure in the app settings.development.json, we specify this as an array value. So if you want to support multiple browsers, you can also specify that inside here. Now with this all set up correctly, let's run this application to make sure this is working as expected. Now based on this feature flag setting, this is enabled based on a percentage of 50 or if it is from a browser Edge. So any request coming from an Edge browser will always be allowed, and if it's another browser, then it will look at the percentage of request. So let's navigate back to the application and run the advanced endpoint. Now in this case, I'm using the Edge browser, so I'm going to get the new algorithm always. So let's click try it out and specify execute. The rain expected is returned as 11%. So if I execute it any number of times, I'm always going to hit the new algorithm. This is because the user agent is going to contain that text. To see this, let's navigate back into Rider, make sure to put a breakpoint in settings and run this again. So when the request is hitting the endpoint, we can see this user agent value has the value for this user agent and it has the Edge inside it. Now because of this, it is matching this condition which is coming from the settings property which has specified it as allowed for Edge. Now let me open up a new browser. So let's say we use Chrome. Let's copy the same Swagger URL and run this from Chrome browser. So let's go into the advanced endpoint, try it out and execute this. Now this time it has hit the new algorithm, but if we execute it a couple of times, we will get the old algorithm also returned. So here you can see this time it returns the value old along with the rain expected. Now if I refresh this, based on the percentage, it keeps switching between the new and the old. Up until now, all the feature flag management and changing of values was happening within the configuration file. This often means we will have to redeploy the application if we need to change the application configuration values. To use feature flags effectively, we need to be able to externalize these configurations. This allows us to modify the application without having to change the app settings or having to redeploy or update our code constantly. In an earlier video, we explored about Azure App Configuration. This enables us to set configuration values using the Azure App Configuration. Now, if you're new to Azure App Configuration, I highly recommend checking that out to understand more about how it can be set up and how it works, etc. Now, if I go into my Azure portal and go to the resources, I have an app configuration already set up so that I can use this from this application. So if I go into the YouTube demo test, which is the app configuration, and navigate on the left side, you can see there is a configuration explorer, which we saw last time, to set configuration values. This also has a feature manager which can be used to set feature flags. Let's see how we can use this from our application. Now, switching back to Rider, to start using Azure App Configuration, let's close all this. Let's navigate into the program.cs. Let's make sure to close all the other tabs. And let's add in a NuGet package. So let's go to Manage NuGet Packages. Let's search for App Configuration. So there is the app configuration.asp.NET Core. So let's select that and install it. I will also be using Managed Identity. So let's also install Azure Identity while we are here. This allows us to authenticate using Managed Identity with the Azure App Configuration. Now, if you want to learn in detail how all this works, I highly recommend checking out the video on Azure App Configuration where I walk all of this in detail. To start using it, let's update this code and specify the configure app configuration and specify the URL for the Azure App Configuration. You can extract this out into your application config. So let's also use the default Azure credential, which is going to use Managed Identity. Going into the startup.cs, we will need to enable the app configuration. So let's specify services.add Azure App Configuration to inject the necessary services inside this application. Let's also scroll down, and for the app, let's enable this in the middleware. So let's call the use Azure App Configuration method. This sets up this application to use the Azure App Configuration as a source provider for configuration values. Now, since when we started, we added all the values inside appsettings.development.json, this will already be used if I run it in the development environment. So to change that, let's go into launch settings and update this environment to be something else. So let's call this test and also make sure to change it for the other profile. So we have two profiles in here which can be selected in Rider from this drop down specified in here. This is also available in Visual Studio. So let's give it as the default. Now, since this application is configured to run in the test environment, it will not load the appsettings.development.json file. So none of these configuration values that we have specified here will come into effect. So for all of this, I will have to add new values in the Azure App Configuration. If not, I can also specify it inside appsettings.json. Now, since we changed the environment, let's go to the startup.cs and remove this check to enable Swagger on all the environments. So let's comment this out so that this gets added for all the environments as well. Let's run this to make sure everything is working as expected. The application is running, so the Swagger endpoint is hit. So let's go into the weather forecast and try this out to start with. So here we don't have the rain percentage property coming up because that feature flag is now turned off. So let's go into Azure App Configuration and start configuring this. So let's switch back to Rider, copy the correct configuration value. So let's say rain enabled. Switch back into the app configuration and add a new feature flag. So let's give the flag name as appropriate. We can add in a label or a description if necessary and click Apply. By default, this is not enabled. So let's check this to enable this feature flag. If we navigate back into Rider, when we added the app configuration as a configure source for this application, we had also enabled to use feature flags. Now, if you navigate into this, you can see there is a default timeout based on which these feature flags are refreshed. So if we scroll down, it uses 30 seconds as the default value. This is being set in the cache expiration interval. So if you go into this property, you can see that this is using the 30 seconds to expire the cache. So after 30 seconds, the configuration values that we have updated will be refreshed in this application. Now, since 30 seconds have passed, let's navigate back into the Swagger UI and click Execute again. This time, we get back the rain expected property since that feature is now enabled. Similarly, we can also go in and enable the other features. So let's go back to appsettings.json, copy the advanced enabled and make sure to add that as well. So let's click Apply and enable this. Now this will refresh only after 30 seconds. So if I go into Swagger before that and click the advanced and try to execute it, it will return a 404 as we expect. I have waited enough and clicking execute will return the data as expected. Now, since the new algorithm is not enabled, we are always going to get values from the old algorithm. To enable the new algorithm, we can also specify this complex kind of values inside feature management. To show that, let's copy this new algorithm enabled, go to the UI back into the feature management and select add. So let's specify the name and choose the use feature filter option to turn on the different filters that we have. So we can specify custom or use targeting or time window. So based on this, you will get the different properties that you can select. So let's specify custom for this example and specify percentage. You can configure this by selecting the dot dot and specify edit filter parameters. Since this has the property value, we can specify that value here as 50 and click apply. Now this is very similar to the value that we have added for the parameters inside of the configuration file. We can also specify the browser filter. So let's copy browser, go back into Azure app configuration and select the browser filter. Let's click the dot dot and say edit filter parameters. In this case, we have the filter parameter as allowed. So let's copy that and specify this value inside here and click apply. Let's click apply again on this. So this saves this to the new algorithm enabled. If you go to this dot dot at the right end, we can also click the advanced edit to edit this in the JSON format itself. Now here we can see this sets up the value exactly as the same. So we have an array property and it specifies the percentage filter and also the browser filter. And it has set the parameters appropriately. Let's enable the new algorithms enabled and refresh it from the Swagger after 30 seconds. Let's click execute, and this time, since I'm running from the Edge browser, I'm always going to get the new algorithm. If I switch over to the Chrome and run the application from there, it is going to switch between the old and the new algorithm implementation. So here you can see sometimes the rain expected is going to return from the new algorithm, and clicking again, it's going to return sometimes from the old algorithm. I hope this helps you to understand more about the feature management library inside of .NET Core. We use this to enable and disable features based on various conditions. As you have seen, we can specify simply a boolean value or even use advanced filters and a combination of them to turn on and off your feature. This is very helpful when you're building new features inside your application. You can use this to avoid long-living branches that never gets merged into your main development code. So you can use feature flags to develop so that you can merge these changes to the code periodically into your main development branch. But make sure you also have good tests to cover that you have not broken existing features. If you like this video, please make sure to hit the like button. If you have any questions or feedback, please make sure to put them in the comments below. If you want to be notified of future such videos, please make sure to hit the subscribe button. This will also help me to grow this YouTube channel. Thank you and see you soon.